Great, so we're going to take a look together at this deer population problem just to help you with the technology. So a population of deer is given by this formula. So make sure when we enter it in our y equals menu that we put parentheses around the denominator. And N represents the deer population and T represents the number of years. So we want to sketch using a table of values because I don't know how many deer there were at year 1, 2, and 3. So I wanted to review with you how to do that on your calculator. It might be difficult to do it on the calculator on your computer while you're also watching this video. So feel free to just kind of watch along with me. I wish we had done this problem face to face, but so I'm going to go to the y equals menu and I'm putting in the function 12.36 divided by parentheses 0.03 plus 0.55 raised to the x power to represent t. So I think you can see that I've got my function in there. I'm going to hit zoom 6, but that's only going to give me a 10 by 10 viewing window. So see how my graph is shooting way up here and I can't see it. So I can hit the window key to adjust the window. And I actually don't need to go past 0 on the x-axis. So I'm going to put 0 in as my number of years. And I'm going to go up to 20. So I want to see what happens. Actually, I might go to 25 to see what happens after the 25th year. And then I can't have a negative population of deer. So I'm going to start at 0 for my y min. And how many deer do you think there are? Let's put 500 in and just see if we need to go above 500. So once you've adjusted your window, you can hit graph. So here's my deer population, and it looks like 500 was enough to see kind of where it's peaking. So now I'm going to go to second table setup, start at year 0 and count by 1. So go to second table now. So let's see, I start at looks like 12 on the y-axis, and it's hard to see these values. I'm just going to scroll down to see the highest point that I kind of need to go to. So at year 20, I'm around 411. So let's see, what should I count by on my x-axis? Can I count by, this is years. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. All right, so I'm going to count by 1 year at a time on the x-axis, and I need to go all the way up to like more than 400. So maybe if I count by 25s, 25, 50, 75, there's 100, 25, 50, 75, 200, 25, 50, 75, 300, 25, 50, 75, 400. Perfect. So this is my population. All right, so I'll give you a minute. You can label your axis, and then I will say the values and you can kind of plot the points. So here's my table. Maybe you even just want to like freeze the video so that you can just see the table. I'm trying to get it so it's not super glary here. I'm going to make it darker. I wonder if that's as clear as I can get it for you. All right. So at year 1, actually I want to go to year 0. So at year 0 there was 12, then 21, and so on. So maybe freeze the video so that you can plot these 10 points, and then I will scroll down to years 11 through 20 in just a minute. So freeze the video, plot these 10 points. I'm going to do the same. So you should have those first 10 points plotted. So now I'm going to scroll down for you on the calculator so that you can see years 11 through 20, since I don't think you have a calculator that you can use the same time as watching this video. So stop the video so that you can see years 11 through 20 and you can get those plotted on your graph. And then we're going to talk about some of those answers together. So pause the video and finish graphing that function. All right, so you should have finished plotting those points. If you want to connect them with a smooth curve to show the trend, that's fine, or you could leave them unconnected. So the initial population of deer we already found out was 12 because the point was 0, 12. So 12 deer were initially present. Find the maximum population of deer if the graph continued on forever. So as I continue to go up, I'm just going to go to like 100 years in my table. See how it's at 412? So it's creeping, creeping, creeping. It's at 411 point something. If I go a little bit further on my calculator, I can see that 412 is this plateau if I continue it forever. So what's the general trend of this population? Is the population increasing, decreasing, or both? So when I look at the trend, if I read this graph from left to right, it's increasing, right? And then it plateaus. Is it ever going back down and decreasing? I don't think so. So I would say it's increasing and then it plateaus, right? It never decreases. So that is the general trend. If you look at question 5, what about the general trend of the rate of change? So the rate of change is actually how quickly the graph is changing its slope. So if I were to look at this graph and kind of hold my pencil here, right? Rate of change is the slope of the line between 2 points. So here's my slope between those 2 points. And then when I go here, isn't my slope getting steeper and then steeper, steeper still? And then what's going to happen as I get towards the top? My slope of my line is going to slowly go to horizontal. So I would say that the rate of change itself, it increases, right, at first, right? We said the slope was getting steeper and steeper and steeper, and then it starts to decrease, right, and gets less steep, then decreases to a horizontal line, right, which is a rate of change of 0. All right, so I would like you to find the average rate of change between year 2 and 5. So that means I need to tell you those coordinates if you don't have your calculator available. So at year 2 in my table, 37, I'm going to say about 37 was my deer population. I'm going to round to the nearest deer. And at year 5, I had 154 deer. So you're going to do y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1, and tell me what you got. So y2 minus y1 over x2 minus x1. All right, so you're going to show me that you got that answer when you take a picture of this side of the paper. And number 7, during what years does the population appear to be increasing at the highest rate? So where do you think the deer population was skyrocketing the fastest? Somewhere in this area, right? If I hold my pen, I'm not quite sure where it's the steepest. Probably somewhere around year, what is this? 1, 2, 3, 4, 5, year 5, year 6, or year 7. So at one of those years, it looks like the steepness of the graph is the greatest. So this says, compare instantaneous rate of change values. So we want to do it at year 5, at year 6, and at year 7. So you're going to be drawing these 3 calculations out for me, but I'm going to give you the coordinates because it's kind of hard for you to do this on a calculator while watching the video. So at year 4.99, my deer population was 153.29. So I'm going to use decimals this time because we're going closer to instantaneous rate of change. So then at year 5.01, it was 154.45. So you're going to calculate y2 minus y1 divided by x2 minus x1 and give me your answer. Then I need to go to year 6. So in my table at year 5.99, the deer population was 213.67. And at year 6.01, the deer population was 214.9. Tell me what the instantaneous rate of change is there. So then, let's see, 6.99, comma 272.75, and 7.01, 273.85. So you're going to calculate 3 different calculations, and whichever one is greatest is going to tell you the year in which the population was increasing at the highest rate. So then number 8 says, during what years does the population appear to be increasing at the lowest rate? I'm not going to do the instantaneous rate of change for this because I think we know where is it increasing at the lowest rate? It's increasing 0 up here, right? So year 20 and beyond, right, the change is 0, right, because it's horizontal. And so the last question, number 9, state the domain and range of the function, what it means in this real life application. I kind of talked about that when I set up my window. If I actually look at this graph and I zoom out, I'm going to see a lot more of the graph. So it actually goes over here and it goes over here. We didn't want to use any negative values for x, right? So in my opinion, x had to be greater than or equal to 0, right? Because you can't have negative years. And y also had to be greater than or equal to 0 because you can't have negative deer population, right? You can't have a -5 deer population. So I would say both my domain and range have to be greater than or equal to 0. So maybe that was a little bit shorter today and you still have to finish up some of the problems from yesterday because that was a little bit long. But you need to just take a picture of the back side of this sheet so that you can show me that you did 6 and 7's calculations. Thanks and have a great day.